So here we are in chi-square video. I'm using SPSS. This is part 2. The first part of the 2-part video series, I did a oral descriptive of the defined terms which were articulated. In the chi-square test, Fisher's exact test, assumptions of categorical data, odds ratio, and phi and Kramer's V. At the conclusion of part 1 of this 2-part video, we talked about chi-square and I was finishing it up, but I had a couple of just points to add. So some of the other measures of association that we should we're asked to describe are phi, which essentially is the statistic is it's very accurate for the 2x2 contingency table, but for tables that have more than 2 dimensions, the value of phi it may not be between 0 and 1 because the chi-square value can exceed the sample size. If that happens, Pearson suggests the use of the contingency coefficient. The contingency coefficient so once again, to describe the contingency coefficient, and this coefficient ensures a value between 0 and 1, but unfortunately it seldom reaches its upper limit of 1. So for this reason, Kramer devised an alternative denoted by V. Kramer's V is used when both variables have only 2 categories. Phi and Kramer's V are identical. However, when the variables have more than 2 categories, Kramer's statistics can attain its maximum of 1, unlike the other 2, and so that's when it's most useful. So as you'll see here, we have expected count is less than 5. One of the things that I noticed in using SPSS is in the chi-square tests outcome, they give you a lot of information here that describe the highly significant result that indicates that there is an association between the type of training and whether the cat danced or not. In other words, there is a significant difference in the pattern response because the expected count is less than 5. The minimum expected count is 14.44, computed only for the 2x2 tables. So that means we're not using the exact sig one-sided table. And again, going back to the chi-square test table, we see that the continuity of correction is 23.5 with a likelihood ratio of 25% or 24.9 or 25%. So 75% of the time the cats respond to food, and that's what that tells us. And Fisher's exact test is they're all zeros, so it's not significant. Well, I've been guilty of bouncing around a little bit, but I really want to drive this home. If you look at the table labeled chi-square tests, this is coming from Crown and Sam, if the exact sig value exact sig value, a two-sided test under Pearson's chi-square is less than 0.05 for the row that's labeled Pearson's chi-square, then there is a significant relationship between the two variables. That's according to Cramming Sam. In my fear of being redundant, I'm going to say check underneath the table to make sure that no expected frequencies are less than 5. And it so states. Okay, so the next thing we're going to do is calculate the odds that the cat danced given that they had affection as a reward. And to do this, you simply divide the number of cats that were given affection and danced by the number of cats given affection that didn't dance. So in calculating the odds, what we need to do is we need to take that number 48, which is the number that had affection and dance, and divide it by the number that had affection but didn't dance, which is 114. Okay, that comes out with a ratio, an odds ratio of 0.421. The odds ratio is the odds of dancing after food divided by the odds of dancing after affection, which gives us the odds ratio. Now that's the odds over odds dancing after food over the odds of dancing after affection, equals 2.8 over the number we just arrived at is 0.421, or the odds are 6.65 to 1. So that's the outcome of determining the odds is 6.68 or almost 7 to 1. So now we're in conclusion. In conclusion, there was a significant association between the type of training and whether or not the cats would dance. Based on the odds ratio, the odds cats dancing was 6.65, or just say 7 times higher if they were trained with food than if they were trained with affection. Food is the ticket. So I just wanted to let you know we're getting ready to conclusion, and my stats dog is back, so I'm back clear again. Tootsie's here. She's here ready to wrap it up. And in wrapping it up, what I would like to do in summary is to say that what we've conducted with Fields and his cats, although I'm a dog person, we'll assimilate them to cats, is that they have taken a population of cats, and as described in the contingency table, we've allocated numeric values to our categorical values for each of the cats, and the behaviors of the cats, we tested the ability to dance, or the propensity to dance, between cats that received food as an incentive or affection as an incentive. And our findings, our prediction was that perhaps there would be more inclined to have cats dance for affection than food. Or some may predict that they would be more inclined to perform for food than they would affection. What we have found is that according to our chi-square analysis, we come up with a chi-square value of 25.36, which tells us that our chi-squared value is 25.36. Our degree of freedom is 1. and our p-value is 0.001, and the odds are 7 to 1 that our cats are more likely to respond to food and to dance for food than they would to dance for affection. And that is our findings from the field's cat analysis of dancing cats. With that, it concludes my video presentation for the homework assignment, and I look forward to next week's machine gun test coming at us. So